Hello, my name is Robert West. Here we go now to do the electrical capacitors. Now this is low voltage here. This is what they call the coil gun, the electric gun, which I got from the internet. Now this here are all capacitors. These are all capacitors. What they do, they charge. You put electricity in and they hold a charge. And over here, this is the power supply. And really, all these capacitors are being charged by this little transformer that just takes 120 volts from the line. This is not big power. 120 volts right here. Comes over into here, changes it to 600 volts DC, or AC I should say, then changes it to DC, and then this goes and charges the capacitors. Then the other wires off from the capacitors come to this contactor, which discharges it here into the electric gun. This here is the electric gun, the electric coil. Now what this is, you see, this goes like this, you see. Now, this is the electric gun. This is a coil I made. This is just plastic. And here, this is a coil I made, I wound up myself. A gauge. And 750 volts DC goes here. And it makes a big magnetic field. And this is a projectile. This is just a piece of metal. That's all this is. A key stock for a shaft on the motor. But it's soft iron. It will take magnetism. And all you do is you put it here. See? You start it about maybe right about there. Somewhere. It's critical where it starts, but we could start right about, it's 4 inches long by 1/8. So you start right about there. See? Right about there. And then, what happens, I'll charge up the capacitors. It's simple. Once it's charged up, then I discharge it right there on there, and then the magnetic field will shoot that out. One switch is to charge, this is to charge, and this one is to discharge. So, as we can see the meter over there, when I go put the meter, see? The voltage is 201, 269, 367, 417. I'll stop it. Then I'll keep going. I stop it right there. Now I'll charge it again. Here it goes. 571, it'll go up to 750 volts DC. That's the common voltage. That's just the voltage they use on the subway track in Montreal. All the subways, 750 volts DC. That's a very common voltage. Now here I go, 750 volts DC, 734, 740. About there I say, that's good enough. Okay, now I'm going to discharge it. What happened there? It hit the door, but it didn't go in. No, that's it. See? That's it. Alright, we're going to have fun. Alright, I'm going to charge it up. I've always wanted to see how that's going to work. I'm going to charge. But I've got to fix that a lot better than what I got. Because these damn capacitors, I got the wire, I got the wire all over the place. Okay. Alright, here we go. Ooh. There it is. Look on the other side of the door. It must have went through that. Yeah, it did. Yep. It went through. Yeah. It got stuck in the door. But it's not a very strong door. It's just too little wood. It's hollow in the middle. But it shows what magnetism could do. It's interesting, and it shows what magnetism could do. That could be used in applications in industry, where you have to put a piece of metal into something, like machine shop or something. I could see this possibilities on this. Here we go. Okay. Now, what I do is this. I shut the power off now. Now, sometimes instead of using the coil and all this stuff, I use this to discharge. Now, wait a minute. Where is that thing? Yeah. See, all this is 6 lights. All this is 6 lights together, you see? And it shows how much power there is in this. See? There's 6 lights. Ooh. That's how much power these capacitors hold. Quite a lot of energy there. And then they'll drain. You see, these act as a load. And then they discharge. They discharge the whole thing. See, we can see here too, I think, with the meter, you see? 264, 252. There's still 200 volts there. The lights are not as bright, but it's discharging, discharging, discharging. There's still a lot of power there. How much is it now? 71 volts. I can't see it. My eyes, they're so bright. It made me go blind. 52, 29. There's still 29 volts. Even though the lights aren't lighting up, it's still discharging. Now, 5 volts. 2 volts. 1 volt. Come on, stubborn. 0 volts. Stubborn, it doesn't want to come. 0 volts. That's it. Okay, guys. This here is a Wimshire generator. And I don't know, this thing turns like this. And when this turns like this thing here somehow makes the electricity. These are the 2 capacitors, the Lennon jars, and you'll see a spark here. A little spark. This will make electricity. It's kind of like a wool. I'll blow the balloon. Watch out, get in there. There. That's a balloon. Now what I do is I go like this. That's what they say in the book, eh? Mm-hmm. You know, in the physics class, eh? See? Hey, look see how it pulls it? You can hear it. Click, click, click. Okay, now what I do is this. Now watch out, it may go boom when it goes here. Sometimes it'll go boom. There.
What about these things?
Yeah, that's just the electrode.
Does it work?
I gotta try how to hold it in. It may be too. Oh! Yeah. Yeah. Well, this is it. This is all my projects I've been doing, and all the things I've done. You see, there's so many things. You know, there's so many stuff, but this is the basic. The basic at the top is the Tesla coil. But I did some other things too, you know, like the coil gun there, that thing there. Not too, I did that, but I'm more interested in the Tesla coil. But the coil gun was good too. I didn't do much in the coil gun, but I'm more involved in the Tesla coil. That's the real fun, that thing there. And with this other coil that I'm making the other side, I want to make it, I know this one is going to be the real bonanza. Like now we got the sparks that far. Just wait when this one's built. Man, we're going to go from there, right out there to the roof. Alright, this is it. I've got to go now. I have to go, and I'm going to be back with my big coil in a few months. I'm going to, and you know, and we'll put that on the internet, and this other one is going to be even better than this one. Wait until I get that other one. And I'm so close.